Please confirm if you can hear me. Is it better now? Is the voice better? Am I audible now? Feedback, please, please, please. Let's respond so that. Okay, thank you. Good. So do we have any experience with Python, or is it just from scratch? I mean, how many of us here have not used Python before? Let's know where we are starting from and where we are headed. Let's set our goals before we proceed. Long, Allah.
No, no, about.
Sorry? Or you can type in the chat. You can say something in the chat. You can type in the chat because I can't make out what you're saying.
Mercy.
Okay, let's just begin. So this is the file that made the internet go crazy, right? This is the 2D that made the internet go crazy. So we are going to start from the base. We are going to start from basics, introducing variables, introducing text sequences, print statements, data structures, and all that stuff, right? So we are going to understand what those are, data types rather. We're going to understand what those are. We won't go intermediate just yet until we've got the basics, and we won't go advanced so that we know kind of what to go where we don't know. Okay. All right. So let's start from. That's why I asked. Does anyone here have experience with Python? Is there anyone? If you are new to Python, just indicate in the chat. If you're new to Python, just type in the chat. If this is your first time, just new. We have one new. Or if you've handled Python before, just tell me. If you've handled Python, we just have one new person, but we have 4 people on the call. I am minus Bakel. Okay, the rest are okay. Good. All right. So basically, everyone here is new. So we'll start from the basics of Python, right? Now, just a brief introduction of Python, right? So the reason why we're using Python, why I think Bakio chose Python, we have C++ there, right? So the reason why I think he started with Python before he actually showed us the code on C++ is because Python is it is beginner friendly, right? It's excellent for beginners. And um, there are its features and functionalities are different from C and C++. Where we are going to see, we'll see the syntax. I mean, Python, we consider it a higher level programming language, right? So in Python, the commands are basically as you speak, right? Just like now, if you want to print something, if you come down to this file, which I'm going to explain, we'll not use this file to explain, but I just want to show you something. So you can see return statement. This is just how you speak, right? We can see from, we can see import, just how you speak, just the semantics of basic English language. So that is Python for us. So that's why it is that way. So it also supports OOP, object-oriented programming, which if there is time, we'll go into later. But for now, we'll just be handling functional programming. We'll be dealing with functions. We'll get to know what that means. And if at any point you don't understand or you don't get any concept, you can raise your hand or send a message in the group, and then we'll reverse. So that is that. I will share my screen now. I'll share another screen that we begin. Stop this. Okay. Please let me know once the screen is up. Let me know if you can see the screen. Can you see the screen? Hello? Okay, good. All right. So we know in basic programming, right? When you're starting to learn programming, the normal convention is they tell you to print what? Hello world. The first thing that it will tell you to do is print hello world. Now, what this print statement does? So this is how you print hello world. So as I said, Python, it uses the syntax for just for speaking. So this is the basic syntax for just to output, right? Now, if I do this, now if I do this and I run it, if you look down here, you see it has outputted it, right? So you can see it. Now, this is the print statement to print hello world. We can print anything here. Now, we are going to understand we can print anything inside there. We can print 2 plus 2, and it's going to print exactly 2 plus 2. Because this inside the string, we can print my name piece is a degree Python basics. So if I want to output anything, which means by outputting something, I want the user to see what I am outputting, right? A user who doesn't have access to this my Python file, this lesson1.py, right? I will use my print statement in order to output. There are other output formats which we are going to learn in the course of this session. So this is a debrief. So whatever I entered in between this quotation and in between these brackets is what is going to be outputted. So that is how we see output. If you want to see 2 plus 2 and all that, that's how we see them. Now I'll be working with a module, which means I'll be working with a file, right? So I created a file, lesson1.py. In my VS Code, it's just easy. I just clicked on new file here and then created the file, right? But now Python has an interactive mode, which I want to use, first of all, to explain this so that we just hit enter and we'll flow. So let me enter the interactive mode. Now let's leave the file for a moment and look here. Now, in Python, we have variables. Now, variables, think of variables as containers, right? So variables is if you want to, let's say you have some apples and you want to store them to collect them, or let's say you go to the borehole and you want to fetch water, right? If you go to the borehole and want to fetch water, you need something to collect that water. You need something to be able to transport the water from that borehole to your house, right? Now, that is what variables are. Now, variables are like containers that we can store something inside. So we can store something inside to access them later. So if I did this, can we still see the screen? Okay, so if I did this, name equals cc. Now, if you see this, this means I have stored this inside this variable. So whatever is on the left-hand side after an equality sign, right? Before an equality sign is the variable name, and whatever comes after the equality sign is the value. So variables come in key, in value, in variable and value pairs. So this is the variable name, and then this is the value. Now, this is an operator which we'll look into operators later, but then this is just the introduction. It's just the introduction. We'll go through them in sequence. Now, we can also do this in Python. Now, remember when I introduced the print statement. So if I want to print, remember I said that variables are containers. So if I want to access what is inside this variable, which is the name, I'll just use my print statement. So I'll just do print name, and I run it. Now, if you see here, it has accessed whatever I put inside this container, which was my variable. and then it has outputted it. Now, Python, you can also run, in the interactive mode, you can also run calculations, simple calculations, 2 plus 2, and it gives you 4, 4 plus 4, and it gives you 8, and all that. So that is that. Then we can also, apart from addition, we can also perform some other functions, some other operations, which is division, 20 divided by 2, and this, it returns it as a float, which we'll see later. We can perform multiplication, which has your asterisk. So we can 2 times 2, and then returns 4. So that is that. Now, discussing strings briefly. Now, strings are like, remember when I did this? Remember when I did this name equals TC? Now, strings are like words, right? Strings are like words, anything you can think of, right? So to put in these words, these characters, this combination of characters, so you pass them to have them as a combination, to have them as a whole, so that when you use your print statement, it can output it. You pass them in as strings, right? So you pass this as a string, and how do you know a string? You can tell it is a string by these quotation signs. This either a single quote or a double quote. This is valid, a single quote, and this too is valid, double quote. Now, so those are strings. Strings can also be numbers too. So we can have, let's use this one and say num. Let's say 28, 2287, and then we want to print it out. We say print num. Now it's going to print out the number. So strings can be numbers too. Strings can also be characters, special characters. Anything you pass in between those quotation signs, those quotation marks will be considered as a string. Let's see. Okay. Now let's discuss numbers. Let's start from numbers. Now we'll be working with this interactive mode here. Now, from numbers, I said you can perform calculations on this interactive mode. Let's leave. I told you this is a file. I told you this right here is a file, which we'll not be using for the time being, but we'll be using the interactive mode. And how did I enter this interactive mode? What did I do? I just wrote my Python 3 and I called it, and I entered into my interactive mode, which we'll not be using subsequently. But for now, I told you we can use the interactive mode as a calculator. So we can do 2 plus 2, and then it gives us 4. We can do 50 minus 5 times 6 times 6, and it gives us an answer 20. We can also do 8.8 divided by 5, and it gives us a float. We'll explain more later. Now, numbers are categorized. In Python, we have types of numbers. We have data types, right? So, boss, back here, we have someone in the waiting room. I don't know if you can let him in. My boss.
What's up?
Yeah, we have someone in the lobby. Someone just sent a message that he's in the lobby.
Oh.
Yeah.
Yeah, I can't see anybody yet, but I'll keep an eye.
Okay. So numbers are categorized into, we have the integers. We are discussing data types now. So we're discussing data types in Python now. So we have integers, which are your whole numbers, 1, minus 5, minus 10, and the rest of them, even 0, right? Then we also have floating point numbers, which are floats. And your floating numbers are what? Decimal numbers. 3.014 minus 0. Anything that has that decimal. Anything that has that decimal is. Okay, no problem. Okay. I wanted this to move faster. Okay, so let's Okay, so we have integers. So we have integers, we have floats, we have strings, and we have booleans. Now, these are the basic data types we are going to discuss. Integers, strings, floats, and booleans. So let's discuss this. Now, integers, examples of our integers are, we have 1, we have -1, we have 0 is still an integer, we have 25, just from -infinity to +infinity. Yeah, those are integers. Now, our floats are anything that have decimal points in them, right? So floats are, if you look down here, we have 4.5. This is a float. We have 0.5 is a float. Anything that has decimal. We even have negative float, so -0.5. So that is it. Now, the next data type is our strings, right? Now, I told you that strings are anything that can be identified inside those quotation marks, either single quote or double quote. So if I have this Python class, this is a string. I can also have it inside single quotes, inside the single quotation mark. And this is a string too. Now, booleans, your booleans come in true or false. True or false. We are going to see how we are going to use booleans later. Now, booleans are data types. Remember that computers store data in zeros and ones, right? That is the binary system, zeros and ones. So in Python, the Boolean data type has just two values. It's either a true or it's either a false. We'll see how we're going to use it. You see it when we are talking about flow statements, that's conditionals. We're talking about if this is true, then do this, or while this, or we are going to see how that works. Now, we've discussed integers, we discussed floats, we discussed strings, and we discussed booleans. Is there any question from here before we proceed? I would just want to be breaking them down as we go. I won't handle everything under each of them, right? I will just give you enough to understand the Python files that we're going to be working with. Then you can go through the research on your own. Any questions from there? Okay. So no question. Now let's proceed. Now in Python 2, we have things like concatenation. There is a concept we call concatenation. Let me write it down here. Now this is concatenation. If you look down here. Now concatenation is like gluing strings together, gluing items together, right? Now we have, let's say we have this. We have name. Let me split Python. Let me split this way. Pi. Then in concatenation, we use the addition sign, while we use our plus sign. Now, this means I want to glue these strings together and present them as a whole. I want to glue them together and present them as one. So I'll write pi and fun. Pi and fun. And then when I run this, you can see it appeared as though I typed it together, right? Now, if I want to store this in the variable to check if this is true, remember what I told you about variables. Variables, you store things inside, right? So let's say I store this inside the variable. Let's say concat. I want to store this inside a variable, and I've stored this. Now, then remember what I also told you about the basic print statement. Print, all I'll be printing now, I'll be printing concat. It's going to output it as one, Python, because here I had concatenated it. So that is basically what concatenation is about. Concatenation, right? Now, Now there are rules to concatenation, right? Just basic rules we are going to discuss before we move to the next topic. Yes, for today. Now we can concatenate strings together. Yes, we can concatenate strings as you had seen here. This is string concatenation. Now we can also concatenate a string literal with a variable, right? Now, what I mean is this. Let's say I stored first one. I stored this inside, I stored pi inside one. This is a variable, remember, a bucket where you can store items to retrieve them later. I stored this inside this. Now, the second, remember I said the first rule was what? You can concatenate strings together. So the first string is ton, the first string is pi, and the second string is ton. And now the operation in concatenation is what? The operator is your plus sign. Right? Now, if I did this, one print, because I want to output, print 1 plus ton, the string. Now let's see what this is going to give us. It gave us Python. Now, why did this work? Because we have what? We have a variable here, and we have pi inside this one, and then we are trying to concatenate it, which means we are trying to glue it together with this one. So what Python is going to do is Python goes into this variable and assesses the value inside that variable. It brings it out and then glues it together with the second string. So that is why. So that's the second row. Now we cannot concatenate numbers with strings. We cannot concatenate different data types with other data types, right? So I mentioned we have 4 basic data types: integers, floats, strings, and booleans. We cannot concatenate integers with strings. Now let's try that. Let's try this. So we have 3 plus 3 number, and let's try it. Now you can see the error. It gave us what? Unsupported operand type for plus integer and string, because we cannot merge them together. We cannot glue them together. It's going to give us an error. So that is that basically. Now let's quickly talk about. Now we've discussed strings, we've discussed float, we've discussed integers, we've discussed briefly booleans. You can go back and read deeply, research about them. Now I want to talk about indexing. In one of the files here, I think was an index used here. Where did I, or was it in mine? Okay, briefly, we'll discuss indexing. Now let's come back to strings. Now indexing is like accessing. Remember that we have this. Where's then our name? Let's output the value of name. Okay, name. Our name is equal to this TC, right? Now, if I want to access, now this is a combination of characters. This name is a variable, right? But inside this variable, we have this combination, this string. And a string is what? A combination of characters. So we have T, the character T, we have character E, character C, character E, and character E again. So we have 1, 2, 3, 4, 5, and 6 characters. Since we have these 6 characters, what if I wanted to access just a single character, just a particular character from this string? Let's say I want to access T. How will I access it? Let's say this is a very long string of text. This is a very, very long string of text. Forget that it doesn't make sense now, but let's imagine this now, right? I want to access this. Let me clear and call it again. Now, you can see it clearly now. Now, let's say I want to access the first character. We'll use something we call index. Now, index works such that you can use numbers, you can use integer values, you can use numbers to access any position of a string. Now, in Python, or in programming, basically, counting starts from 0, not your original one. So the number system starts from 0, right? Even your decimal system, in decimal, where you use your fingers to count, it starts from 0, right? So we have 0. The position for T now is 0. Position for E here is 0. Let me take it back, clear this, and use TC, which is shorter. Okay. Oh, this one will. Let me name it again and use Python this time. Okay, now we have position for P is 0, position for Y is 0. Position for t, position for y is 1. Position for t is 2. Position for h is 3. Position for o is 4, and position for n is 5. So this is index. These are the indexes for these particular characters in this string. Now, if I want to access it now, what I will do is simply call the variable, because to access it, I need first of all to access the bucket. I need to access, if I want to access the content inside the container, I'll first of all need to access the container, right? So that's why I'm accessing the variable name. I'm accessing the variable name. Then I pass in my square brackets. Now to print out just P, the index, I pass in my index here. And what is the index for P? The index for P is 0, right? And I do this. Now you can see it has just given me, it has just returned P. If I want to do for Y, I return 1. It gives me just Y. If I want to do for T, I return 2. It gives me T. And if I want to run for H, I return 3, and it gives me H. If I want to run for O, I return 4, and it returns O. It gives me O, and so on and so forth. So that's basically index in Python. Now, there is also negative indexing, right? All we've been doing has been positive indexing. We also have negative indexing. And negative indexing is, just as the name implies, it's literal. We use a number, we use the negative sign. So, and negative indexing, we usually use it for things like, we use it for backward indexing, right? So if I want to access the n now from behind, I can just do this, -1, and then it gives me n. So this is a negative indexing. Now let's see this. Gives me O because I'm starting from behind. And if I did this, 3, it gives me H. If I did this, where did I stop? 4, it gives me T. I don't know. Any questions? Do you understand that? Any questions? Okay. Are we good? Are we good? Can we proceed? Okay, beautiful. Now, we discussed strings because we are building from the basics, right? We are building from the basics. Why from back is it not 0? Okay, we have another question. Why is it not 0? Now let's try that, right? Now let's try printing 0 from behind and see what it gives us. Now 0 from behind starts from the beginning. Understand? Now negative indexing to access the last element. Now in indexing, naturally, this is the formula it uses, right? It uses n-1, where n is the length of the string. Now, remember our container, the variable is what? Name, right? So if I check length of what? Name, let's see what it's going to give me. Now, it gave me 6, which means we have 6 characters inside this. Now, let's count. We have P, which is 1. We have Y, which is 2. We have T, 3, H, 4, O, 5, and N, 6. So these are the number of characters, right? Now, but if I want to access, let's access 6 now. 6. Let's remember that it gave us 6 characters, right? When I try to return the length of the content of the values in that variable, it returned 6, right? That was the length. Python, if you count it with your fingers, it gives you 6 characters. But let's try accessing the 6th character in that variable, and let's see what it gives us. Now you can see an error because what numbering starts from 0 to 1. So that is n-1, 6 minus 1. So 6 minus 1 is the last character. I can as well do the 6 minus 1, and it gives me what? N. So if we start from 0, back to your question now, if we start from 0, it means you're accessing the first character, and then -0 is still 0. I don't know if you understand. -0 is still 0. I mean, let's say, okay, let's say you had, okay, basic math, we have this. Let's try this. We have 4 minus, right? Minus, then we have another -0. minus 0. What do you think it's going to give us? It's still going to give us 4, right? What if we had 4 and just 1 minus 0? It will still give us 4. So negative 0 is the same thing as your normal 0. There is no absolute basis to it. Okay. So that any other question before we move into slicing? We are still on strings. We've discussed integers, we've discussed floats briefly. Now let's move to strings. We now understand what indexing is all about, right? Now, for slicing, now we have this remember our variable name was name. This was a variable name. Oh, this is too long. Let me cut it. Okay, clear, and then name Python. Python, yes. We have Python 6 characters inside the name variable. Now, what if I just wanted to access I don't want to access py, I just want to access th and on. I don't want to access on, I just want to access py, th. Or probably I just want to access th. That is what comes in between. I don't need the py, I don't need the on. How do I do that? We do that with what we call slicing, right? We use the slicing operator. And how do we slice? Now, we still use our square brackets for our slicing. To do that, we do this name. I want to access from y to n. I don't want to access p. So what is the index for p? The index for p is 0, right? So instead of starting from 0, I start from 1, and I pass in my colon. I can pass in, I can decide, I will explain what this means now. I can decide to pass in what? To leave this open. To leave this open, it's still going to give me ython. If I run it, it gives me just, you can see it here, ython. Or I can decide to declare it just y to the last item, which is 6. And then it gives me ython. What if I wanted to access this from t down to n? What would I do? I will start from what? 2, and then that is t. So that is slicing. It just, as the name implies, I told you that Python is high level. It works just as you speak. The semantics are no different from how you interact with your friend on a regular. So that is it. So we are slicing the characters, we are slicing the items inside this variable, and we are returning the remainder of the slicing. Understand? So that is that. Now, in slicing, we can have multiple colons. And I'll tell you what those mean. Now, there are different formats to slicing. We can do this. We leave, remember, the slicing, the syntax is this: start, end, and we have step. Now, this is the syntax: start, end, and step. Now, what this start means is this. Forget this error. This is not what I wanted to return. But what this start means is this. Now, for your start, we have name. This is the start. This is the position for our start. So our position, where do you want to start slicing from? So we want to start from 0, or we want to start, if we want to start from 0, we can write 0 there, explicitly state it, or we can just leave it blank. So leaving it blank means we are starting from 0, right? Then the same thing applies to the end, right? So if we want to end at the last character, we can also leave it blank. So which means we'll just have one colon there. So when I run this, it gives me the complete variable, the complete value for that variable, which is Python. I might as well decide to do this 6, and then it gives me the complete thing. How about step? Now, step is optional, right? Step is optional. Now, step would have us jumping indexes. What that means is this: if I include this, start from 0 to 6, yes, start from 0, stop at 6, then in a difference, I want you to jump 2 characters at a time. Remember, at this point, the default is that it jumps 1 character. That is why we are able to print P, we are able to print T, we are able to print H, we are able to print. What if I wanted to jump a character in succession, right? So after printing P, I want to jump Y. After printing Y, I want to jump T. If you print H, I want to jump O, and then it prints N. How do I do that? So I use this step. If I use step 1, this is what it gives us. It gives us the full thing because by default, the step is 1. But if I want to jump two characters at a time, I use this. So that it has jumped what? Y, it has jumped H, and then it has jumped Y, it gave us T, it has jumped H, it gave us O, and it has jumped N, and then it gave us the end of the line. So that's for indexing. Then how about, now there is this algorithm we use to transverse string, right? You want to print strings from behind, right? You want to print strings backwards. We usually have like 2 lines of code, right? Where we are going to understand what all this means in due time. But usually, let's say I want to do this. I have name equals Python, the string Python. I have this. Now I want to print this. Let me use this file. Let's work with this file now. Now I have name equals Python. Then I want to print it. I want to print the strings from behind, right? I want to print N, then O, then H, then T, then Y, then P. Now, usually what C and C++ will have us do is this. It will have us declare a temporary variable, right? Now, for our indexing, we can just start with, let's say, name. Now, because I'm starting from the last character, what do I do? Minus what? 1. So if I print -1, then where should it end? It should end at what? It should end at 0. Now, let me remove this. Now, it's going to end at 0, right? But I want to print this. So with my print statement, print this. And by the time I run this, wrong with that debugging. Okay, let me clear this. I run this direct. I go to print name. Let's see, print -1, and then run this again. So it gives us Python. But usually, what we're going to do is, what this will help us do is, we are going to start from behind and pass it into a variable. So we'll start from this. Now, why this didn't work is that this particular one, we are supposed to have a return statement. So we are not collecting any return at this point, right? But if we did this, print, let's see, let me return it, sorry. Backward, back 1, back 1 equals name. This is, let's start from -1 because we are starting from behind. -1 to where? To 0. -1 to 0. And then I come down here and print back 1. And I run this again. Okay, no, I missed something here. Yes, -1, this step. So, okay, Python, it has mixed P. Okay, I started from this. I'm going to start from, but okay, 1, leave this empty, and then run this. So you can see now. Now, what this means is usually usually in C and C++, what this will have us do is we are going to declare a temporary variable, right? Okay, let's say when we want to swap variables, let's not talk about backwards now. When we want to swap variables, we need to declare temporary variables and all that. But back to slicing, back to slicing now, right? So basically, if I want to rotate a string backwards, I will just do this, run this, and then it rotates it backwards. So remember, this is our start. There's a variable missing here from our start. Let me use a terminal. I don't like this. So this is our start. Okay, maybe I need to declare it again. Python. Now, as I was saying, if I want to return the characters backwards, what I will do is what? Num1, let's say back1 be equal to name. Remember, we are dealing with the variable, which is the name, because we are trying to access the values from that variable. Then the syntax for indexing, the syntax for slicing is what the start. Where are we starting from? So I told you that we can leave that empty. Now, how about the end? I also told you that we can leave that empty. Then the step, how about the step now? So the step means start from behind, right? Start from behind, one position behind. Remember that the default for step is 1. So what if you are starting from -1, which means it's starting from N, right? Then O, then H, T, Y to P. So that's what that's going to give us, and that gives us. Oh, I didn't print. Sorry. Print back1. And then it has given us everything in reverse. So that is basically that for that. Then we also have a function. You can see I used one function when I was explaining things earlier. I was trying to explain the length of my string. So that's the length function. So this length is going to give us the length of a string. When we get to discussing function, so you are going to understand how we can create our own function, and what inbuilt functions we can use, and how we can use them, the return statements and all that. But this is just added knowledge for this session. So any questions before we proceed? Any questions? Are we good? Any questions? Okay. Beautiful. So we are good now. All right. Now, I introduced data types. Now, the data types I told you, the base data types I told you we had were what? We have integers from negative infinity to positive infinity. We have strings characterized by the double quotes or the single quotes. We have floats, right? Their characteristics they are identified with the decimal point. Then we also have booleans, which are just two values, true and or false, right? Then we also have data structures. Now, data structures are like, now in strings, in data types, now let's see this. We cannot do this. Let's say num equals this. Then I want to pass multiple values. Now, strings can only take one value at a time. That's a string. Data types, rather, can only take one value at a time, right? So I can only pass in 1 into this. If I try to pass in 1 and 2, 1 and space 2, it has given me an error because what? 2 hasn't been what? Identified. I can only do this if I'm passing it as a string. I can only do this if I'm passing it as a string, then it accepts it, right? I told you strings, quotations, don't forget that. Now, for this reason, data structures were created, right? Where we can pass in many things that we would want. So we have several data structures. Now, one of them is the list. We have the list as the data structure. We have the tuple as the data structure. Sorry, spells that wrong. Tuple. We have the sets. Yeah, and then we have the dictionary. Right. So these are the basic data structure. We have list. We have tuple. This. We have list. Let me write it again. List, tuple, set, and dictionary. Dict. Right. Now let's discuss list. Now lists, we were talking about, we're dealing with numbers, right? Now let's still use the data type. I hope you understand. You understand the difference between the data type and the data structure now, right? I hope you understand that. If you don't, please call me back so before we move ahead. Okay, that's good. So we have lists. Now for a list can contain, now your data structures can contain your data types, right? Your data structures can contain your data types, right? Now, this is what I mean. We have our data structure, list. This is the syntax for our data structure. Let's say we are creating a list. I told you, just as the name implies, list, it is categorized with still the square bracket. Now, I have one, let me use 1, 2, 3, and 4. Now, this is our list. These are lists. You can see I've been able to include many values into this variable list one, right? Now, if I want to print, what if I want to output the values list one? Here's what happens. It outputs it as a list. How do we know it's a list? If you can't tell from this syntax, from the square brackets and the commas, the spaces and everything, there is a function we can use to declare that, which is our type. Then we say list. What we are basically asking, what's the type of list one? And it tells us here it is what? A list. So that is that. Now list can contain, your list can contain other data types, not just integers. Now let's do this. I have an integer represented here. I can have a string here too represented. Python. I can have a Boolean represented, true. I can as well have a float value represented. So I can have 5.0. I hit enter. No error. Successfully, thank God. And then we print our list one and we have that. So that is list. So your list can contain other data types. Data structures can also contain other data structures. Now, your list can contain a list too. Now, we have all these data types. We have the integer represented. We have the string represented. We have the Boolean represented. We have the float represented. We can also have a list. And how do we create a list? We do that with square brackets. So we can have another list. You can see second, third. So this is this. Now it has stored. Now what if we want to print, we want to review? Let's see what's inside our list. Now you can see we have an integer inside here. We have a string inside here. We have a Boolean. Then we have a float, and we have another list inside here. Now, remember we talked about indexing. Everything I had mentioned earlier, we'll be using them as time goes by. So we are going to, every session we'll be having will be unfolding what we had learned before, and we'll be reusing them inside what we are working on currently. Now we are talking about indexing now. I told you to index, we use what? The number, the index number. Now, what if we want to, now I told you the numbering starts from 0, right? So our position, the number 1 here is at position 0. Let me clear my screen and call this again. Number 1 here is at position 0. Python here is at position 1, true, position 2, 5.0, position 3, and then this list, position 4, right? Now, since that is the case, that being the case, we can output what if we just want to access position 1, the value for position 1, what do we do? So what we can do is this. We'll say print what? Print lists 1 at position what 1, close a bracket and close this, and then we just have Python, right? Now we cannot use this again until we store it inside the variable. Remember that I am just printing here to output. I'm just printing to output, right? I'm just printing to display right here. But what if I want to reuse this now? So what I can now do is bring back our discussion on variables. I will store this inside the variable, and that will make it accessible. So I can say pause 1 equals this. And then I've stored inside the variable so that if I want to use this anytime, I want to use that Python, what is inside that variable anytime, I can easily access it, even if I don't know what it is. Let's say I don't know the content of this list. I don't know that position. I don't know that 1 is at position 0. That Python is at position 1, 3 is at position 2, and 5.0 is at position 3. And the rest of them, right? What if I wanted to just access any one of them? So what do? I store them inside the variable, and then I print it. I print my variable POS1. So it gives me Python. How about accessing this list? Let me increase the number of this one. Let me increase the number here. Let's say 4th and 5th. Okay. So now that we have that, what if I want to access the second, this is 0, 1, 2, 3, and 4. What if I want to access the 4th item in this list? What do? Okay. I print what? List 1, access the 4th item. Now it gave me an entire list. So I am not accessing 1, I'm not accessing Python, I'm not accessing true 5.0, but I'm accessing an entire list. What if I now wanted to access something inside a list, which is inside another list, right? Which is a nested list, right? What do? I use my double indexing, which is similar to your metrics. Print position 4. Let's print position list 1 at position 4. But inside this position 4, yes, I'm going to print this list, but then I want to access 4th, 1, 2, 3, a 3rd element inside the second list. What do? I do this now. 0, 1, 2, 2. I run it, and then it has given me 4th. Any questions? Any questions? Yeah, Chairman, you can speak.
Okay, please, is the list the same thing as array?
Beautiful. Yes, your list is an array. In Python, you consider it as an array. In C++ and C, yes, you call it an array. So this is an array. Yeah. So what are the characteristics of your array? How can you tell something is an array? Chairman Chukebuka.
Sir?
How can you identify an array in C++?
Come again.
Can you hear me?
Okay, it's actually JavaScript. I know it's
okay. In JavaScript, how do you identify an array?
There are indexes and elements.
Indexes, just that.
And they are in square brackets.
Now, okay, they are square brackets. Okay, that's an array, right? But now this okay, yes, you're right. Yes, that is an array. So it's just the same thing as an array in your JavaScript, basically.
Okay.
Yep. So any other question? We've discussed lists. There are methods in lists. We have list methods, which I don't want us to go into now, but we can review them with, let's say, dir. What is our name? List 1, right? this one. So these are lists. Let me check this. Dir, this one. This one. Now, these are all methods in our array. We are going to discuss methods when we go into, after discussing functions and after discussing OOP, when we get into OOP, discussing classes and all that. But these are things we can use in our list. Let's say, okay, for instance, let me just use one of these now to make an example. Now, remember that our list has list one. The content of our list is what? Python, true, 5.0, and we have another list, right? Now, what if I want to remove, I want to delete an item from my list? I can now call my method. I will just say list dot what? List one, sorry, dot what? Remove. Now let me print. Let's see this. Sorry, remove what item, what position do I want to? Let's say I want to remove at position 1, which is 0. This will, X is not in this. Oh, sorry, 1. Sorry, 1. So now, so it has returned none. I will explain what this means. Where is it? Where is it? So these are our list one, right? Our list one. Now you see at the beginning, our list one had what? Object. It had an object 1, right? At the beginning, it had this integer 1, Python, true, and this. But using that remove method, I have been able to remove what? I've been able to remove that particular one. Now, remove is a method that you use when you know the actual value of that for that index. You can see when I call this, I need to mention that particular index. I need to mention that particular value, not the index, right? So I need to mention, if I say remove at position, now Python is at position 0. If I say remove at position 0, which is the index, it doesn't observe that. It gives me an error. But what observes that is something we call pop. Now pop starts from behind, right? So if you want to move, if you want to use pop, I can say this position 1 pop. If I don't use anything here, it will remove this particular pop. If I don't include any arguments inside these brackets now, it's going to remove this entire list. Let's try that and see. It has cut it out. It has cut it out and copied into another list. Now let's print. I think it creates a new list. Yes, it creates a new list. So you can see it has removed this particular list inside this other list. But if I want to remove a particular thing now, I can just mention the index using that pop. We will discuss methods as we progress. So let's say I want to remove Python, I will pass in my 0 index. Remember that remove, I have to pass in the exact value. To remove Python, I'll have to pass in Python here for remove method. But I'm using pop now, which means I have to pass in what the index. And then it has removed it. And let's check the content of our list. Now you see Python is out. So the only thing we have inside this list is what? True. And so there are many other methods as we saw when I dir'd this. So we have extend, we have index, we have insert. You can go back and read about list methods, or you wait until we get to that point. We'll just touch on a few, and because I think this we only have today and tomorrow. Then if my boss sees that I am doing well, he can decide to continue. Next week. My boss, I hope I'm doing well. Back here.
Now that could decide your fate, so no be you. As for me, I can understand everything you're saying, so you are doing well in my opinion.
Okay.
But if they say you're not doing well, what can I say about it?
Okay, it's all right. So this is just the introduction, it's just the basics. I want us to cover list to cover the data structures I mentioned, the list, the tuples, the sets, and the dictionaries today. Then we call it today and wait for tomorrow. So we discussed lists. That was list briefly. And let's not forget we can also index. We can use index in a list as we had seen. We can use slicing. We can slice in list. Now what I mean is this. Oh, I need to clear this. Let's go back to our original lists. This was our original list. Is it complete? Oh, there's an error here. Okay. No. Okay. Now let me show you something. This was our list one. Okay. All right. Close it again. Oh, sorry. This lady Walla. Let me remove this and this. Okay. Now indexing. Remember what we learned about indexing. Now indexing. What if I want to access Python? I want to access Python. You know I'm going to do this. List one. Position what? One. So that's Python. How about I want to access true? I'll do the same thing. So that was we discussed indexing and the rest of them now. So let's go over to the next one. Let's discuss. Should I discuss tuple first? Okay. Now there's something I didn't mention in list. Now lists have characteristics. I should have mentioned this earlier. Now in list, the characteristics in list are the list is mutable. Mutable, which is one. Forget. Oh, let me use my text editor. A list is mutable, mutable. The list is also ordered. Now I'll explain what this means. ORDERED. Okay. Yeah. Now it allows duplicates. So now, these are the characteristics of your list. Now, by being mutable, what this means is this. These are our lists. You can see that I deleted, when I use the pop method and I use the remove method, I had deleted objects, I had deleted items from that list, which means it is mutable, right? So, and this list now, if I do this and I print list one, this is for ordered now. List one. Now, just as I have written it in this order, it's going to output, it's going to come out in the same order. Print list one. Now you can see one, Python true, 5.0, and my inner list, right? So that's the order, right? That is why we are able to use indexes for them. Now we have some data structures that that we cannot index because they are not ordered. They are unordered. But for lists, we are able to use indexing to access them. But for other data structures, for some other data structures, I think one of them we cannot use the index. So that is for lists. Now let's talk about sets. Sets. Now okay, no, before sets, I think sets, if I need to discuss sets, I'll need to go to my draw.io so that I'll explain with using the Venn diagram. So, but let's discuss tuples before sets. I think I'll discuss dictionaries or tuples before sets. So now we saw that lists, right, and strings have so many things in common. Now lists and strings, they have that indexing attribute, that characteristics in common, right? Because I can index, if I can index, which means I can slice, right? So that is basically what it is. But now for tuple, now how are tuples identified? Tuples. Now for our list, we create lists with this. List one. This was how we created our list. List one is equal to what? This. Then we have the first character here. One. The first object. We had the second one. We had the third one, and we had the fourth one. Yada yada yada. We had this. How about tuples now? Now let's create a tuple. Now for your tuple, we don't use square brackets. For a tuple, we don't use square bracket. What we use is we use your normal brackets, right? So for a tuple, we can do this equal 1, 2, 3, and 4. So this is sorry. This went into 40. So these are tuple. So if I check the type, let's check the type of tuple. Tuple. You see, it gives us the type tuple, right? Now let's create multiple. This, let me clear the screen and create. Let me populate it. Well, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. The reason I'm doing this, you understand why I'm doing this. Now I want to print soup 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, let us see. Now, for tuples now, let us try to access. Remember, in list, we're able to use the index to access the item at a particular position. Let's try it for tuples. Let's see if we can access it. My boss. Hey.
And your large was the problematic.
You guys just click everything. Okay. Now, let's try seeing. Remember, for the characteristics of list, the first data structure we discussed, we said it was mutable, which I explained as you can modify, right? Delete, add, remove, basic CRUD operations, right? Now, how about ordered? Is it ordered when you print, the same way you wrote it in that fashion, does it appear in that same way, in that same order as you had listed it out? How about duplicates? Right? List, you saw that I had 1, I had 0, I had another 0, which means that it can contain what? Duplicates for list. How about tuples? Now, let me edit this and see. We have 1, 1. Let me use something that we're going to be able to tell the difference. So I've written 1 twice. Now, let's start from this. Let us print. Hey, this is my terminal. Let us print. Oh, God. I never used this. Oh, I've done it again. Print soup 1. Soup 1. Now, let's see. I had declared a tuple and I had listed 1 multiple times, right? So it means 1 appeared twice, which means that it is what it allows duplicates, right? If it didn't allow duplicates, you would see that it wasn't going to list 1 twice here. So that is it. How about the order? Is it ordered? Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it is ordered. Now, what's the next characteristics we are going to check now? Let's check if it is mutable, right? If we can modify it, we can delete. How do you do that now? Let's check the methods inside the list, inside the tuple rather. Tuple 1. Now, it has, let's see. It has the count, right? It has, okay. It has the count, it has the index. Let's see what other method exists apart the ones that don't have this done there. Other methods exist. Okay. So you notice that they are immutable. Now let me try to remove. Let me delete this and call our list again. Oh, okay. Create our list again. Now let's try to delete an item. Okay. Okay. Let me try to delete an item and see how that works for us. See how that's going to work for us. Now, I want to access tuple 1, tup 1 at position 0. Now it gave us 1. It gave us 1. Now, what if I want to I want to add something to that list? Now, let's say, I think it has an add. Let me check here. To one. It should have, these cannot be all. It should, okay, count and remove. It doesn't have any remove. It has reduced size of index. Okay, it has index, which we've checked. Okay, but lists are not mutable. Tuples are not mutable. Now, they are immutable. But they are ordered. They're ordered. We're going to see examples of this. They are also allow duplicates. All right, so that is that for tuple. Right, now let us try deleting. Let's try deleting. Let's say remove. We don't have any remove method, but let's try that. Let's try with the same method that we use for tuple1 dot what remove one. And let's see, it has no attributes remove. How about pop? Let's try pop. Pop has no attribute pop. So can we actually add? The only way we can add is if we create a new tuple. Okay, let's do this. Let's create, we have this tuple. We have this as a tuple. Then let us say num equals let's say 5. Let me something that's going to tell you. Let me say 1000. Right. And now let us try to add num inside tuple. Right. Now we've not seen any method that we can use to add directly into tuple1, right? When I did when I checked the directory of tuple methods, we didn't see any method that we can use to add directly. But let us try this with our indexing and our slicing. So let's try this now. So I want to pass to, so let's say tuple1 equals what? What do we do here now? Tuple1, right? At position what? Now this is position 1, this position 1, this position 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So basically this position 21, because I added an extra one here. So at the end, this end is 21. So let me add 21 inside here. Let me add 21. So from 21, I want to add num equals num. Now let us see. Now what this logic means is the content, the value of this variable num. I want to pass the value of this variable num into what? Tuple at index what? 21. I don't know if you understand that. Do you understand this logic here? It's just simple logic. Thumbs up. Okay, good. So I want to pass this. Oh, there's a thumbs down. Someone give a thumbs down. Who is the person? What's the issue?
Just come again.
Hello?
I said just come again.
Okay. Okay, now, were you here when I explained the concepts of indexing and slicing? Were you here? Hello?
Yes, I was.
Okay, now, do you understand how slicing works and how indexing works now? Because that's what we are trying to use here,
Yes,
most especially indexing. Okay, now, so this is our tuple, this line here. These are tuple. I have declared this tuple. Forget this. I declared this line into tuple1. right? So our tuple contains what? This array, this tuple, right? 1, 1 to 20, right? Then I'd also declared another variable, 1000, and assigned it the value 1000, right? Now, remember that the position at this tuple ends at what? The length of this tuple ends at what? 21. Let's confirm that. What's the length of tuple 1? Length tuple 1. Tuple 1. 21. So that is where it ends, right? So what I'm trying to do now is I'm trying to pass tuple 1 and num. Oh, this is tuple 1 num equal 1000. Okay, now what I want to do is I said tuples are immutable, which means they cannot be mutated, they cannot be modified, but they are ordered. The way you write them is the same way they will be attributed to you. They allow duplicate. That was why when we printed tuple 1, we still saw 1 and then we saw 1 again. If they didn't allow duplicate, we won't see the second one. So that was it. So we are trying to prove that they are actually immutable. You cannot modify them. Right. So I want to pass this 1000 into this original tuple and see if that's going to work. Right? Do you understand what we are trying to do now? The person who asked the question.
Yes, yes.
Okay, so let's do that. To do that, I'll say tuple 1 equals tuple 1 at position 21 equals what? Num. So this num, the 1000 is going to replace this variable num, and then it's going to pass it into position 21. If it works, then now you can see tuple object does not support what? Item assignment. It is not mutable. It is immutable. Right. But it doesn't mean we cannot create a new tuple. We can create a new tuple and pass that value. But for the particular tuple that we've already declared, it doesn't work. Do we understand that now? No, do you understand? Okay, let's quickly move over to sets. Let's discuss sets. I need to open my draw.io. I will change screens. Let me switch screens. Just give me a minute. We are almost rounding up for today. Share this screen. Okay, can you see my screen? Oh, okay, good. Good. Where is my pencil? Where's my pencil? Come on. Pencil. My pencil is still here. Okay, let me just use this. Now, remember our set theory, right? Our Venn diagram. Now, let's imagine this box is a Venn diagram. We have this, let me duplicate this. We have this. Oh, no. I need it to be. Just a circle. Then it's there's supposed to be feel no, don't feel, beautiful. This is what I was looking for. This one, don't feel too. Don't feel. Okay, good. So we are making progress. Okay, I'll duplicate this again. Then turn it. So this is our Venn diagram, right? A high school Venn diagram. Now we have some numbers here. Let's say we have 5. Let me duplicate this. We have 7 here. Duplicate this. We have 11, 5, 11, and 7. Then over here we have 8, 8. We have H. No. See here. What's going on? Then we have 9 here. Okay, I think that's enough for this. And then let me give this one some unique numbers. We have 4 here. Then we have 14 here. Okay. We have 1. We have what number should I give? 15. We have 21, and then we have 20. Just some random numbers. This don't matter. Right. Now we can see that, okay, I didn't name them. So this is A. Move this here. This is B, and this is C. Now look at, we have 3 we have 3 sets, right? This is a set, this is a set. We have set A, we have set B, and then we have set C, right? Now for set A, our set A, what are the values inside our set A? Now in sets, the convention, remember in list, for list, the convention was what? The bracket, the type of bracket we use for lists are what? The square brackets. For tuples, we use the normal bracket, the circular bracket. But for set, we use what? The curly bracket, right? So in set, this is how we declare our set. In your mathematical set, we have for set A, what are the values inside set A? We have what? 5, we have 7, and then we have 11, right? We'll come back to that. Extend this. Now, for set B, move this one up a bit, move this one here. For set B, what are the values inside set B? We have 8 and 9, We'll come back to that. For set C, what are the values? This is not aligned. Okay. So for set C, what the values we have 14, 14, we have 4. Okay, so this is the high school set theory. Drag this to the. Okay. Now in set, there are properties for their set properties, right, in Python, just as they exist in your mathematics. Now the first one is unique numbers, right? Unique numbers. What are the unique? What numbers are unique to A? We have what? 5, 7, and 11, right? These are the unique numbers. How about the numbers that A? Now the unique numbers. Let me come down. Now, how about the numbers that A shares with B? What numbers do A share with B? We call those what? Intersection, right? Intersection, and now it is denoted with the what? N, small n, A intersection B. Intersection B will be equal to what? A and B will be equal to what? 20, just 20. And the intersection C, how about A intersection C? A intersection C, that's the numbers A shares with C. A and C, it shares what? 21. 21. A the and goes on. Let's work with just those two first so that we don't take time. Now we have A intersection B and A intersection C. Now you see A intersection B, this A and then A intersection B, which means the numbers A shares with B, right? So which is just 20. Now let us declare this in Python and see how that goes. Let's come down here. I'll delete all these. So I told you to declare a set. We have what? Set what? Set 1 will be equal to what? What are our numbers? Set 1, we have 11, 5, 7. We have 21 and 21. 11, 5, 7, 21 and 21. Sorry, I will share my VS Code soon. Then set B, for set B, what do we have? We have 8, 9, 1, 8, 9, 15, and 20. 1, 8, 9, 15, and 20. Set B. Set 2. 1, 8, 9, 15, and 20. 1, 8, 9, 15, and 1, 8, 9, 15, and 20. Yes. Okay. Let me go back to. I'll stop presenting here and share. Go back to VS Code. So you can see the new screen, yes? Can you see the new screen? Great. All right. So we have two sets. Set 1. Set 1. Just copy this and paste. I'll just copy this and paste. We have two sets, set 1, and then the second set, set 2. And then I paste it here. So we defined set 1, and we've also defined set 2. Right. Now, set has some properties. Remember, we discussed 4 properties when we discussed 4 characteristics before 3 when we discussed list and tuples. We talked about mutability. We talked about we asked if it was ordered. We asked if it was what? Mutable, ordered, what again? Nobody. Hello, are you with me? Hello. Okay. Okay then. So in list and tuple, we asked if it was ordered. We tried to see if it was mutable, right? Mutable. We are going to also do the same thing for set to see if they are mutable and if they are ordered, right? So let's check if we print. Let's print set 1, set 1. Now, this is not the only way we print things in print. You can see in that robotics file, we use an F string, which is another way to print, but we've not got there yet. This is just the basics, so we'll get to using other things. So these are prints. Now you can see that we printed what? Set 1, but this was the order that we wrote it in. 11 first, 5 comes next, 7, 20, 1, and 21. But look at it here. It started from 1. Let's try again and see. 1, 25, 21, 7. Let's try again. 1, 25, 21, 7. Now, for this particular session, it remains that way. Now, if I close this session, let's close this section and I open the session again, I declare my set. I declare my second set. Let's print set 1. Set 1. 1, 20, 5, 21, 7, now and 11. This is a new session and a different order altogether. How about set 2? Let's try printing set 2. It doesn't appear the same way it was written. So which means what? It is unordered. It's unordered. Now let us try to see if we can access it by using the index. Let's try to see if we can access set 1, the second item. Now remember what I said. If it is ordered, which means it is what? Indexable. Because if it's indexable, which means that this 11 will be at index 0, this 5 will be at index 1, 7 will be at index 2, right? But where these ones, where their positions change, right? Where their positions change, today it is here, tomorrow it is here, tomorrow, which means we cannot really access them, because anytime we try to access it, thinking it was how we wrote it, it's going to give us a wrong value. But let's see that now. Set 1 at position 0. Let's try it. Now you can see set object is what? Is not subscriptable, because that is all semantics. It is not indexable, right? So that is it. So the first property of set is not what? Ordered. It is not ordered. Set is not what? Indexed. It is not mutable, immutable. Immutable. Okay, let's try to see if it is mutable and see if it has multiple, if we can store several values in it. Now let's see, these are set 1. Now let's see if we can have a duplicate. Set 1. Let's try passing in 11 again and printing set 1 again. Set 1. Now let's print set 1. Now you can see what? It is what? We cannot have duplicates in them. So we have two 11s here, but they didn't appear here. So does not support duplicates. And let's see if it is mutable or if it is not mutable. Now, let me try. I want to try to pass this set 2 inside set 1. That is how we are going to check if we can modify set 1. Now, let's see. Set 1. At the last position, right? Set 1 at the last position. What's the last position? Let's see. At the end, we start from what? Position what? 1, 0, 1, 2, 3, 4, 5. So let's start from position 5. 5 not inclusive to the end. This is the end. Then we'll pass in what? Set 2. Set 2. Set does not support option assignment. Now let's check the directory and see if it's going to give us anything interesting to discuss. Set 1. Now, all right. Now, set, we can see that from this directory now, it is mutable because what? We can remove, we can pop. Those things we saw in lists, we can do them here. And let's try this. Set 1 dot remove. What are we removing? We're removing 11. Now let's print set 1 again and see if 11 still exists. Now you can see 11 doesn't exist. Now how about 7? Let's remove 7. And then print set 1. Now you can see 7 is out, which means it is mutable. Now, for other ones, now remember in our Venn diagram, we have what? We have difference, which is what? The elements, the difference in your Venn diagram is what? The elements, the difference are elements that exist. Let's say we have set 1, difference, the syntax is minus, right? Hope I've not forgotten here. Set 1 minus set 2. Beautiful, yes, set 2. That's the difference. Set 1 minus set 2. What is it going to be? Now, set 1 minus set 2 is going to be the difference. The elements that exist in set 2 that are not in what? Set 1. So what are those elements? The elements that exist in set 1 that are not in set 2. What are those elements that are in set 1 that are not in set 2? Let's check. We have 11. We have what? Let's check. We have 11. We have 5. We have 7. We have 21. 11, 5, 7, and 21. So this is the difference. 21. Now, if I come down here, come down to my VS Code, and I run this now. Set 1 dot set 1 dot what? Difference in brackets are passing what? Set 2. What do you think is going to give me? It's going to give me 21 and what? 5. Because this is 21, doesn't exist here, and what? 5. Because I had already, let me declare set 1 again. Remember, I deleted some elements from here. So let me declare it again so that it will give us the right thing. Now, let's run that difference again. Now you can see exactly what we wrote here. 21, 7, 5, and 11. So that is the difference. Then how about intersection? Now, intersection are all the elements that exist, right? Remember that in set, when we checked duplicate, what happened? Was it able to support duplicates when we wrote 11 multiple times? Now let's see the 11. And then let's print set 1. So you see, it was able to support duplicate. Now, since we have this now, let's see the intersection. Now the intersection will be all the elements in both set 1 and set 2. How do we do that? We do that with set 1 dot what? Intersection set 2. All the elements that are in set 1 and are also in set 2. We have union. Union refers to all the elements and all that. We can go through them at our own free time later. So that is that for set. Any questions? Any questions? All right, let's discuss dictionary, which is our last topic for tonight. We won't take time on this one. So dictionaries come in. Remember, this is how we declare list. List for your list. We use what is square brackets. This is an empty list, to declare an empty list. Now, to declare an empty tuple, we use what? This. But now, to declare an empty set, okay. Now, I will explain why set and dictionary, they tend to, they have conflicting signs, and there is a way that you can address, right? So, declare an empty set, we will not do this because this is not, this sign is for dictionaries, which we are going to see. But to declare an empty set, we don't just use the curly braces, we do this set, this is an empty set, right? But to declare an empty dictionary, this is what we do. Dictionary, dict1 equals this. So this is an empty dictionary. There's a reason we didn't do this. There is a reason we didn't do this. Because this is for dictionaries and this is for tuples. So set is the only one that comes in them. It doesn't mean that we cannot, it doesn't mean that we cannot convert, it doesn't mean we cannot convert tuples to set or convert lists, lists to tuples and tuples to lists and all that. We can have those conversions, which we'll see later, probably tomorrow. But back to our dictionaries. Now, dictionaries, this is what we have. This is a syntax for declaring a dictionary. We have dict1. Dict1 will be equal to, they come in key value pairs. So we have a key, your colon, and then we have a value. Now, this value, key and value, could be any data type. We could have a number for a key and a string for a value. Let's say, good job, right? So if I print, or let's say I say dict2, sorry, print sorry, dict1. Dict1, 2. Now you can see it's going to give me, it's going to return what? The value and not the key, because I passed in what? The key here. So this is the key and this is the value. So these are dictionaries. We can have data types inside other data types. We can have list inside list. We can have a list inside dictionary. Now let's see this. We can have, let's say we have fruits. Fruits equals. Then we can have, let's say, what other fruits exist? Let's say citrus fruits. Citrus. Then we can now have a list as a value. Remember I said it comes in key value pairs. So this is the key, and then we can have this as a value. So Yeah, so sorry about that. The battery, they've taken the light, and so I have to leave now. But basically, we've covered basic data types, we've covered basic data structures. Tomorrow, we can look at the type conversions and then progress from there, see where that takes us. So that is that for today. Any questions? Any questions? Okay, so no questions. All right, that's good. I don't expect any questions now anyway. Everybody here an engineer. So my boss, Bakil, hello, Bakil. Oh, Batman, don't go sleep. Uh, Batman no dey Gotham City again now. Wetin happen now? He don come from Gotham now. He no dey Gotham again because. All right, so you can drop questions in the group chat. We'll be able to cover a few. So inside that robotics file, you can go through how you can still go through it, understand what was done there. You can see how variables were declared. You can see the mathematics in them, how typecasting was done, additions, subtractions, and all that. We haven't got to modules and importing other libraries yet. When we get there, we'll be able to cross that bridge. I'll try to be twice as fast as I was today, so that from Tuesday, as back your promise, we can start running simulations. So that's that. All right. Good night, everyone. Okay. Yeah, go on. Chukwuebuka, you have a question.
Okay, can you hear me?
Yes, I can hear you.
Okay, so please, so far so good. I think little by little we are getting knowledge on Python. But I want to ask a question about something in particular. In the plots part. So when you were like looking at all those code line by line, that is
Okay.
when as Bakel instructed us to do and overdo.
Okay.
At that initial point, did you understand it or you had to like have you used that library before? And at that initial point when you were going through it, did you
Yes.
understand it
Yes,
instantly?
I've used NumPy before.
Okay, not NumPy, it's the other one, the plot part.
Matplot is just basic plotting. Once you understand how to use libraries, understand how to import them, you understand all you need to do is to go inside them, check the methods inside them, then use them. So that's basically what. So there is no magic to it. Okay, if there is any
Okay,
magic,
so
that's just the magic. So
okay,
that's it.
you went to the library itself. Okay, you entered the library and saw what everything
Yeah.
was all about, right?
Sorry, come again.
So okay, you know the way it's a block of code. These libraries are block of codes. You
Yes,
went to the
yes.
library itself and just went through them.
No, I didn't have to go to the library. I introduced, if you see, I was using dir, right? I was using dir because
Yeah.
I was trying to get you guys familiar with dir so that nobody even
Oh,
asked me what dir does. But I think you've already got the
oh,
picture of what dir does, right? So dir,
yeah,
it just gives me all the objects inside that particular object. When we discuss OOP, you see how everything is an object, and then these objects have properties, right? So it gives me all the
yeah.
properties, all the methods, all the attributes inside that particular object, and I can access them. So all I need to do for new libraries, after importing the libraries, what I'll just do is I'll just go into them, see what I can use under them. If it's anything confusing, I can read about them online, then come back and use them. So it's nothing really difficult. And and the truth is nobody actually carries all those libraries in his head, right? So
No.
you just need to go out there, research what works, what might work for you, the particular feature you want
Okay,
to implement, and then implement it. So that is it.
okay, okay. No
All right.
problem. I understand that. Thank you very much.
Yeah, good. You're welcome. Any other
Yeah.
question?
All right. So we'll call it today and we'll see tomorrow. I hope we'll be early because we started about 10 minutes late today. So we'll see tomorrow. So that's it. Let's call it a day. Good night, everyone. Yeah, if you go back group chats, go to make noise. Make person no sleep this night.